Hello, ladies and gentlemen, and welcome back. Yes, I finally actually have my hair untied because why the fuck not? But I can see why I always usually have it tied up. Have a hair tie in my hair. Give me a minute, I need to buy my hair tied. It's also like there's some fucking fucked up things about it's fucking windy outside, right? My hair was blowing all over the place. So yeah, there's definitely also some minuses about having long hair, especially here in Denmark. I don't even know how many meters a second the wind is going at. I wonder if you can check. I can actually check that real quick. Yeah. On. It's currently 6 degrees Celsius. It feels like minus 6. Holy fucking shit. Oh fuck. It's 11 meters a second and it's dropping, don't worry. But still, 11 meters a second. That's quite something. It was at something like 14 meters a second before. 11 meters a second. Beat that, Americans. But anyways, enough with 11 meters a second wind, which is the norm. We, and by we I mean I, need to make a PS2 driver, aka a keyboard driver, aka an I8042 driver, controller driver. Now I do actually also have my old repo, the old one up here. I can figure out how to fuck zoom in. Thank you. And zoom a little bit in like this. And I don't even have my microphone up. It's here. Get a more crispy sound. Let's find a place where it locks down. Okay. But yeah, get that crispy sound in there. Holy shit, that's crispy. But anyways, I have my old PS2 driver here. And don't worry, yes, this is bad. Let's split it up into a few parts. And we'll go through the first part. Yeah. This is the normal 8042 controller driver thing. We have some status symbols, we have the we have the ports here, external symbols, and then we have a few things here. Now, one thing that I don't do here, I do not, make this a device, which we will do today. If you might know, Here, I have some devices. Really put this you down. Increase you here. Probably also close you. Yeah, we have all these device types here. And a PS2 driver, for example, goes under a device character. Because we get 1 byte pretty much out of it. Now with that, we also have this. We also need to implement this. Which this actually doesn't need to be sector offset, just offset. And offset in some way, shape, or form, and also a count. I have added support for okay. So the way that you initialize the PS2 controller is actually pretty much is by sending commands back and forth to it, and then checking whether things are connected or not connected. So for devices like for emulators like QEMU, with QEMU you have the first controller right here. The first PS2 controller port is usually attached to the keyboard, and the second one is attached to the mouse. That's usually how it goes, but of course in actual hardware, it can be a little bit different. Actually, scratch that. It isn't just a little bit different, it's a lot different. And if we go down into initializing the PS2 controller here, then we can see a few things actually. I fucking shit on me. But we can see a few things. So first of all, the BIOS first of all makes a way like actually initializes the PS2 controller. Of course, if there's a USB keyboard, it doesn't. So the way that you should technically do things is you should initialize USB controllers first. There's nothing to do with PS2 controllers or devices. However, it's basically because that there are some legacy support things for PS2 and USB. You need to determine if the PS2 controller actually exists by doing some things, looking at the ACPI things here. We are not going to be doing that. Disable the devices. Now we actually get into actual PS2 territory. So yeah, devices connected to the PS2 controllers, to the PS2 ports, must be disabled so that they won't send data at the wrong times. Okay, so yeah, that is like that. This A7 here is for the second port, by the way, second controller. Flush the output buffers. If any data has actually been sent through, then we want to actually get rid of that. Set the controller configuration byte. Pretty much disable IRQs, disable translation, and enabling a clock signal for both ports, not translation, but yeah. Perform the self-test, control self-test. This is the kinda an acknowledgement to say that, hey, we are doing shit, we have shit. Determine if there is a second channel. Right now we are on step 6, by the way. Then perform interface tests, check if it actually works, enable the devices, and reset the devices. This is how we do it. Now, let's map those things to what we have done over here, or what I've done over here with my old thing. So let us find an init function that's handlers and keyboard. Initialize variables, fuck that one up. Yeah, is device present is not known. We're saying that we're pretty much saying that, hey, we don't know if anything exists. First of all, disable the two ports, yeah, by writing the commands. Let's map also this to over here. Disable the two ports. I think here we are checking for bit 1. Bit 1 in the status is if the output buffer is empty or full. We also need to do that at some point also. If it's still one, if it's still 1, we do an error saying that things ain't working. Return. We disable the interrupts on for both channels. Write command 20 right here. Read it. Write command 60. And write it back. Let's see about that. Yeah, so here so actually forget wait 2 things. Yeah, here we're actually flushing it, sorry. Yeah, we need to check that too. Yeah, we are setting bytes, bits and whatnot. Here we are doing bit 1 and bit 2. Yeah, that's bit 0 and bit 1. Yeah, okay, yeah, so we enable. That should be, I don't know what the fuck I did last night. Disable. The disabling interrupts for both channels. That's what we do right now. Then we check if the channel is actually present by taking this thing here, checking byte 4 and byte 5 apparently. That's the clock ports. Then if they are present there, perform the self test here. Then we will enable them again. Then check present for again. First enable the first channel is enabled so it exists. Okay. Why the fuck did we do it up here then also? I don't know. Anyways, but we apparently check it here also. Oh, that's if it is unknown. Yeah. We disable them again. Don't ask me why. Test first channel. Wait, what? What the fuck? What the fuck have I been doing? The second channel, enable interrupts again, and also set the handlers. Then enable the channels by doing all this. Wait for acknowledgement. Wait for response. If both of those are good. We can go down here, check what type of device is connected, sending out this byte and reading the ID. And that's then done. Yeah, because that's then port 2, which we don't use. Sending 60 to the CMD. Then getting... Huh? Okay, that's weird. And yeah, if it's present, then we actually initialize it proper. Right in here. By doing some things, I guess. So yeah, I guess that is all we kind of need to do. That's the only things that we need to do. So let me actually like make a boolean I8042 wait or check status. Wanna do a bit. We also need to then also include std full. Let's just split the one up again. We also want a time, probably. Like we did up, like I did up here. Six. Then we will say 4 size, or actually we can just like do uint 16 I is to add 2 ticks. Then if I8 all that read from status and by how did we do that? We set, we can do a bit get this thing by bits. Now what this one is, what this get bit here is pretty much, it is a macro that I've made here. And when we expand it, expands to, we get this. Read from the ports hex 64. Move it over to the right by bits and end it with 1. If that is successful, then we want to return true. Else, we want to return false. We don't have any resemblance of data as of yet. So yeah, and we can make other functions later. But now, I want to really quick go into here. I'm gonna throw you over here really quickly. Then get you. Actually, let's do it. Focus over here. Then define an I8 there. Output buffer. Date. bit 0 as then input buffer state 0 or 1, and that should actually be the only thing. As for that, at least. Yeah. Oh yeah. Let's go back to this one. The bit 1 and bit 0. There is input, or actually is output buffer. Wait. Actually, let's do a wait output buffer empty for x ticks. Output buffer. Whilst this is not true, whilst it is, what did I say here? Yeah, whilst the output buffer is still has something in it, I want to do an want to do a read of data port. Then we can check this again. If it still has something in it, then there's something wrong. So we failed it. Else we passed. I don't know why this sometimes just like goes away. Wait till buffer is empty for 1,000 ticks. Right down. In configuration. Actually, should I just do just disable interrupts here only? Because where do we then? Because then we perform the self controls. The controllers test here. Then we enable them. Then we do some other things. But don't think that we are checking them any further. Read again. Check if they're enabled. And then we enable interrupts here. Right back in. Yeah, so we just do it all. Then we need to perform the write test. That means port command AA read from port data. If it's equals to 55, and actually if it's not equals to 55, I want to do a, I don't even have a log debug. Huh, I don't even have log debug. That's something new. Debug slash debug.h log error module. I know I don't have it. Self test failed. And we need to return away from there. You didn't return anything? Nope. Good. Let's then do a definition of module I82. Okay. Yeah. Let's actually also implement all of these things, I think. What the fuck is this even used for? Ah, for the pointing. Oh, okay, that makes sense. Let's just check whether they are present or not. We can do that by make some quick variables over here. I42 first, second, maybe also the last one too. That usually also helps. There. First channel device. Then we need to do this. And note there is some others. Right here. That. Okay, let's see. These ones are not up to us. Channel, no device connected. That sounds like something that would be in here. Device presence is not known. Device not present, device present, and device present but error state. No device connected, yeah. When do I use that? That's on the device. Oh, that's in the keyboard. And then, yeah, okay. That actually makes sense then. To have, maybe. So yeah, which channel is actually is the like yeah, which channel is the keyboard and mouse and if they're connected or not. Yeah, that actually so controller present. That has nothing to do. Huh? That's also because they changed the name, right? Yes. But don't even set it. Really. No, you found something. You said yeah, it's not used. At all. Yeah. First channel present, second channel present, first channel device and then second channel device. So then when we need to, I don't know why I always want to like say 8088 apparently. That is then all that no device connected. Second channel device. Someone's got that calling me. Give me a minute. Okay. Great thing that I just took that call. Oh well, I need to then let's go to the next town over, I can see. Right. Anyways, back to this. We don't know if they are present or not. That this should all work. I hope. If it doesn't, then there's clearly something wrong. So let us. Love that. I love that called this like these two init keyboard instead of anything else. Extendedly, damn. But anyways, we disable the PS2 keyboards, the PS2 channels. We flush. We disable the interrupts. We skip this part because we don't need it. We perform controller self-test. Then we need to enable the PS2 channels again. And then we need to check for what channels are present. So if we look over here, I want you up real quick. And check down here. So flushed output, set that one, perform that one, determine if, yeah, so we can then determine, perform an interface test. Oh, okay. Then we just like test both like the things. Okay, good. Then enable the devices, and then reset the devices. And then we need to either receive bytes using by pulling, which we're not going to do, by the way. We're going to be doing it using interrupts. It will all be interrupt based, like things. Was this the correct one? Nope, it wasn't. It's this one. So let's then also make one for the input state. Wait until the input buffer is empty. Yeah, so there we just like read it, I guess. Check, I guess, and then if it's not, I guess, then continue. I think. Yeah, anyways, then down here, actually, two things, wasn't it the flush output? There was output. Oh, here I am. Agree. Yeah, wait output buffer. Wait for the output buffer to be empty. And then we need to do perform that thing, which we're doing here. Then we need to determine if what channels that there are. Step 5. Determine if there are 2 channels. The way that we do that is by sending a command A8 to enable the second channel and read from that thing, determining if byte 5 is enabled, it should be cleared. And this for the second channel. And send that to disable the second port again and clear bits 1 and 5 of the. I want to disable those and enable port 2. Okay. Yeah, bit command A8. I had another thing right here for commands. Up here. A8 here. Yeah, that's to enable the second port. Shouldn't we also enable the first port? Maybe? What do we say here? Yeah, here we enable both of them. Then we check presence of channels by getting the byte, checking if it's in an unknown state. Then controller configuration byte, checking bit 4 of that for the first controller and bit 5 for the second controller. Isn't also that is what they said, right? Good. Bit 5. Yeah, so yeah, we check bit 5 and bit 4. Okay. So yeah, we want to write to port. Right, yeah, I can also just send a command. A8. And we also want to do AD. We also really quickly need to say that if first channel is actually supported. Semicolons. To enable the channels, then we need to read in the controller configuration byte, which we have a macro, which we have a function for. This one. We read it, we then hit bit comp, then we check down here. It was bit 4 and 5. So if bit 4 is enabled, then we can say that the first channel present, it is indeed present. And the same for channel 2. If here we need to check if we are actually supporting it. If we can pretty much just copy this downhill, Control C, Control V. I8042, second channel there. That's present. Else, we'll just say that the device is not present, and non-present, and non-present. Yes. Disable the 2 ports again. We can do that up here. This. And yes, remember the semicolons, could you? Then you're saying test first channel. And yeah, that was, what was that one? It was perform interface tests. Yes. You need to write AB and wait for 0. Is this read data function here? What's this? What? Yeah, that's just is to read. Wait for output filled. Wait until buffer output buffer full. Don't we wait for it to be cleared? Oh, right. Yeah, we're reading. Good morning. That's actually just like and 6. Wait, this is, I have a literal fucking function that does this for me. Which I could just have done this. Check output state, bit, and then ticks. Then check input buffer state. Yeah, so here we then want to say Wait output buffer empty. Wait, I think I want to do. I kind of want to have both of them. Make some smaller simple functions up here. Actually have the things down here. Then in here, actually there will be a, yeah. We shouldn't be using this function because else we are getting into a deadlock where we just repeatedly try to check for the things. How to spell bull? Yeah, for write, we wanna wait until it is cleared. So this one is cleared. Let's just do that for 500 and there. That's 250 cycles, I think you call it. Then we need to check if the output buffer is built. We need to say that is value equals value. In this case, it is for clear. As if it's 1. Or when it's 0, then we can. Okay, wait a minute, 2 seconds. Yeah, we can do this extremely much more cleaner. Do a for loop. Ticks for the amount of ticks here. I don't know why the hell this one comes from. That comes from the pit. Why the fuck are we using the pit in here? Oh yeah. Then we need to just read the status port. Get a bit from the status port. If this one is, if that one is true, wanna continue. Actually, it just says to wait. Yeah, we'll make this word again. The wait input clear. That's an output. Yeah. Wait output. Wait until output buffer is built. That's not. Is that bit 2? Status. Output buffer. Why are we checking bits? We're checking bit 1. Oh, there. Fuck. Technically we don't need any kind of like loops here. Just a while. While it is, yeah, whilst it's, what is it? Whilst it is 0. Yeah, so whilst it's empty, we do shit. Then in here, we can do some of the same things, except for this time we actually need the ticks. There, whilst actually we can also just like not, we don't need the ticks. Now this is if it is whilst it is actually true. Then down here, we can actually just check the input state. I think, no, wait, this is not the input state, but we kind of need a thing like this, but also not like this. That even makes sense. In here, down here, how did I do it? I set from 0 to 1000, check the status port, get the input. That's 1. Let's then here. If it is true, wanna read from data port. For 1000 bits. For 1000 times. We want to check it. And if that this is still true, then we have made an absolute big error. Couldn't flush output buffer. Then so wait until the output buffer is filled and wait until the input buffer is empty before we write anything in. The rest of these actually go through here. Yeah. Yes, Gucci. Okay, so now that we got that one out of the way, it took some time. Then we just need to test for they are actually there. And now we don't need to check. Now we don't no longer need to do these things here, because now we have a concrete answer if we actually have it, if it's present or not. So first channel, If the first channel is present, write command AB read, then we should read 0, 0. Then we test successfully. Let's do that. Command AB if a reads from data is not 0, then we will then do an error. Failed. What was it? What is it actually called? Like this definitively failed input test for channel for first channel. Will not break, but we will say that it is present, but with an error state. Pretty much, we don't know what is happening with it. The same thing we need to do for the second port too. Second channel. The second channel thing was A9. Yeah. Read if it's 0, if it is if it's not 0, then we, yeah, of course, do all that. Then wanna enable interrupts again, enable channels again. Well, we apparently have 2 new functions. Wait for a first channel, wait for acknowledgement. Holy shit, that's a lot of functions. Read status. Check for, what is that? That's number 1. That is, that's the input buffer. No, that's the output buffer, sorry. Check for output buffer. Read data. If it's FA, then there was an acknowledgement sent, and else we will error out. And as for response, that is just check status for that. Really. Enable any PS2 port that exists and works using command there and command there. If you're using IRQs, recommended. Also enable interrupts for any usable PS2 ports in that one, set bit 0 and bit 1. Then set it with that command. Yes. We pretty much just need to do what we did over here, pretty much. So pretty much all of this. We don't really need like to check what type. Actually, do we? Maybe not. I don't know. But anyways, have I totally forgotten to actually like write that one? I did. Perform step 7. 6, sorry. Yeah, the same thing. Perform an input perform interface tests. Yeah, and then we just need to enable the devices. Step the number that shall not be named right after the first number. Yeah, then we just need to do this and implement. Actually, we don't really need to implement those functions. Actually, do we use them again? Yeah, we do use them again. For acknowledgement there, acknowledgement there. How many acknowledgements do we need? Holy shit. Like a fucking clingy girlfriend. Anyways, we need to read the configuration byte. Then we need to check whether we could also just do it here. Plus enable interrupts. We already have them here. Yeah, because we just need to check if they are present or not. If you here are present, then we just need to attach an handler, control configuration byte, enable translation, and enable interrupts. And that's handler 1 and handler 12. Yeah, so we need to handlers and handlers. And we need to then bit set bit, what was it? It's bit 6, which I will nearly say that that's 5. Yeah, bit 5 and bit 1. Actually, is it 7? 2 seconds. That's down here. That's bit that is bit 0. Good morning. And translation, that's bit 6. Yeah. There. Enable interrupts. Bit set. Oh, do we actually need to unset that? I have a feeling that we need to unset that. Translation enable is 1 and disable is 0. We needed to enable translation and enable that. So enable and enable. So enable, that's number 1. And translation enabled. Wait a minute, what the hell am I doing here? I'm ordering translation. Scan code set 1. Yeah. And then I am disabling bits and not setting. I'm clearing bit 0. But that will disable it. Won't it? Yeah. Any other things with this name here? No. Huh. Well, anyways, then we'll just do it my way, I guess. Embed 6. Enable translation. What did I do? What? How did I do it up here? Yeah, I said unset to disable first PS2 port interrupts. We'll not be setting it just yet. We'll set it right when we're done here. That is then bit 1 only. Then we will write back new configurations that we have. Yeah, now we're done with that. Then we just need to enable the things here. Write first channel. Huh? How the hell do you write to the first channel? Clearing buffers, then write to there. And also the same for second channel, except for here we're saying oh, that has something to do with this, I think. Full bit 1 there until it becomes clear. And then otherwise write data, yeah, and then here write default to the command and then write else error out. Oh. Okay, so we simply just need to copy all of this, paste it over and into here, and rewrite all of it. Ain't that just great? Write, read, status port, status port, read, status, read, u, read status, down. I'm not doing ticks. Yeah. If the current time, whilst the current time is under that one plus ticks, Okay, let's just do ticks equals 0. Whilst ticks is not 0, whilst ticks is under 200 there. We'll just like do this, delete that, delete that. So we'll then check status 1. Bit get bit number 1, which was input buffer state. Do we need to do input buffer state? I think that this is input buffer state. But don't we already do that in here? We're checking if it's full here. Huh? Yeah, so we should already be checking in here whether whether the output buffer is filled. Right here. That was just unnecessary code, I guess. And then we need to do something of the same things over here. I usually don't write void here. And you need to be a boolean and bool. Read the status for number 1. There was upper buffer state. Yes. The read there and all that. We also need to rename them. I think that there's another more prettier way you can do this. But don't count me on that. Write to data port with data. Write the command. Yeah, so here it's different. Okay, you know why all of this is like why the fuck am I using this? Am I also getting an interrupt in between there? Huh? Because the only time where we are, at least over here, where we are like updating these is in the handlers. It could very well seem like that we are getting an interrupt right smack middle in here. Why? I don't know. If I could tell you, I would, but I can't. Sadly. Again. 6. 6. 6 plus plus. 6 plus plus. I forgot to do also 6 up here. 6 plus plus. Then we just... Isn't that it? That should be it. Yes. Now, the only thing that doesn't need are these two. Of course, the buffers themselves. Let's do this. Let's then also do this. Give them the correct names. Then throw them out. We also actually need to actually define them. Right here. So we only need to do lowercase here. Standards haven't been like the most intriguing thing right there. Yeah. So do all that. You should know what. Oh, okay. So that's why. That includes std int .h. Now you guys should have a type. Yes. You shouldn't have that. We're already saying that this is an error. Ran out in pulling first channel. Ran out in pulling second channel. Okay. Now we're finally down here. Presence. Stable, check. Enable interrupts here. So yeah, we need to write AE, write to the first channel FF, and wait. For the second channel, we need to write A8. Can't remember what A8 was. We can quickly figure that one out. A8, these are to enable the things, enable the channels. That's what U, and U. And we don't need that. We don't need any error identifications. We just need to do port 2. Write to data port. Write to the first port. Wait for acknowledgement. I forgot to do that. I8 all that. Device present. there. Then we can do this. Write to data port. There, there, and there. uint8. You don't need to be uint8. You need to be a boolean. You also don't need to be a uint8. You need to also be a boolean. And yeah. Then we've reset them. Then what we then need to do is check types. After resetting the device should not be in streaming mode. Disable, yeah, but to be sure disable streaming. Okay. Read ID. Wait for a response. Wait for an acknowledgement. Wait for the response. Then data. Then check again. Wait for some more data. Check the data. Check. Say that is the keyboard that's connected. Do that. Enable interrupts again. Oh. Wait, so what we did up here, so what, huh? So I'm saying here, enable interrupts. I'm disabling interrupts. I'm enabling translation here. Over here, we are then enabling the interrupts. Huh? Tell me a piece of code that's more messy than this. Please do. I don't think that there is anything that's more messy than this. Let us just see how many fucking errors there's here. First of all, I can't do you as of yet. First channel present. There. First channel present. That's non-caps. Yes. We're not going to be doing that. First channel present. Enable this again. I'm 100% sure that this is lowercased. Redo it to be uppercased. Yeah, and actually let's just like redo all of them over here. Maybe also do the correct thing. Write to second channel. Write that. Then do that and then do that. Good morning. And do that. I don't like having voids in there. And hello microphone. You also do exist. More things. You. Luckily the functions are just like a drop-in replacement. Pretty much. Wait for first channel. And do this one. Then do this one. Unknown device. Right first channel, all that. What's that command? What command was it? It was F4. You don't even give anything out. Why the hell would you then do that? F4. Oh, enable scanning command for the device. Hmm. And then we can do a few things there. It's not possible for the second PS2. Yeah, no shit. Why are we then saying keyboard channel keyboard initialized? That should be initialized but no connector. First channel keyboard, huh? The channel 1 in it. Right here. Why the fuck are we... Okay. Again, find me some kind of code that's more messy than this. And we also no longer want to do you. With the device ID of that. First channel device ID, all that. Squishy. Remove these ones. That one. Now, like I know that GCC is going to scream at me. Literally, I know. Mouse connected. Else, something's wrong. Do all that. Here we don't have an error. And all this. No backslash ends here. Nice is there, Second channel device. No, wait, not second channel device, but second channel present. There, second channel present. We need to probably make that an info. Okay. Let's go on the main. Then go up here. Go where all the drivers are. Drivers slash IO slash this one slash that one. Now we could do this anywhere in the world pretty much. Because we're not accessing, we're kinda accessing memory, but not that much. But still, I am going to be doing it in here. That was not the correct terminal. This is the correct terminal. Right, I haven't even told. Yeah, printing works now. What? Right when I get this working. Let's just do a make here. reach the end of that. That's because that you need to be a void. Yeah, you're not going to be returning anything because there's a third one. I guess it's the fourth one. Nope, okay, Gucci. Read data. That's just read from teleport. I have a feeling that we have a lot of these. I better just to simply like to have them. PS2 read data. And here we just had a pickup right now. YouTube I've got a fucking comma. Well, comma's now going to be my new worst enemy. Right to just like to right. What was that called? It was called something. No shit. Usually everything is called something. Send. Why is it called send command? Write command. All of them. Write command. Here we teleport. Unknown module sh. I don't think that things are going to be working, but anyways. Okay. But anyways, we have printing working in QEMU. Now, whilst I'm going up here and all this. Wait, it worked? Count me as being fucking surprised right now. Like, actually surprised right now. First channel present. And the ID is AB. Channel, if the channel is AB, and it's translated, so it can be any one of these. Which I guess makes sense. Well, anyways, the problem with printing text was the way that I was laying out the font. So, yeah, this is some debugging shit, don't worry. So previously, so what was happening was that I was writing doubles into this file, into this font file here. Like actually writing, for example, if there was a 0 here, there would be 2 zeros. This 0 would also be 2 zeros. This 7E would be 2 7Es, and so on and so forth. So we only had half of the data. Now I fixed that, plus also some bugs within actually like the driver itself, and now things should be working. Hopefully. I need to register two things. I need to register arch slash there slash IRQ. Then let's just like steal the handler. Like at least some of the handler at least. We'll be rewriting like much of it again. So I want you to have all the things that you possibly can have. Then when we plus enable interrupts here, then we need to do IRQ register handler. That's for number 1, I think. If I'm not fully mistaken, that was for number 1. Yeah, number 1. I hate that that one is not named correctly. I686 IRQ register handler. I don't have ODC. What was I about to say? I don't know. Well, fuck it. Status. Wouldn't it be a better idea if I actually just did a read of the status here? Then read data port. Then everywhere you possibly can do it. Move pointer. Buffer is full. We can't like process the data as of yet because we don't have the relevant functions as of yet. Handler data is there. Where the fuck was this from? That's not the one that I was trying to get. It was this one. You're from there. That's under arch there. That one. Here. And again. Send. End of interrupt. Now I actually have a fucking standard. A naming standard. So now we're gonna go through all of these and also like just like rename them all. IO. Let's go wait. Big. Get mask. Set mask. Higher weight. Look at how clean this is. Then we're just having this. That. PCI 1. Offset PCI there. and auto end of interrupt. Think Rister? Oh shit. That is a long ass name. I need to do it twice. There. Sleep, probe. Mask. Everything needs to be pretty much lowercase. And then get driver. Yeah, driver down. That should be it. Damn fucking semicolon. Yeah. So now, when we're here, press space or nothing. Classic. Do you get anything here? Unhandled interrupt. 33. 33. In ISR 33, that is number 1. Yeah, interrupt number 33, that should be IRQ number 1. IQ above 15. Turn. STD debug? Why the fuck am I throwing it into STD debug? I shouldn't be throwing it into STD debug. I should be throwing it into include debug/debug.h. I should be throwing it into error from the module, and this is not the PCI. It's the IRQ. Get driver. IRQ get driver. Huh? Like every single thing should have been updated. Apparently not. IRQ. Now, if I didn't do this, what will then happen? If I then go up here, it's still the ISR. It doesn't even go through. Let's check the ISR, which says ISR handle. So if it's the interrupt is above 30. There's an unhandled interrupt apparently. Do you know what? I don't believe in that. If we go over here. Yeah, it's above 30. What? Let me do some debugging. On module interrupt is -u rex interrupt so What are we then saying over here? Interrupt is 33. Okay. It's because that is by the way that I am like doing it? No. Like we are registering it. And then we're doing shit. But also the IRQ doesn't even like do anything. Actually, yeah, it does. We say IRQ register handler. And then we are unmasking. Huh? Why the fuck am I? Okay, if I go on the hall, then IRQ is here. No PCI found. Okay. We do have PCI, that's at least good enough. We're setting the mask for both of them. We're registering this thing for each one of those. IRQ, if IRQ is above 15, return. Did I have an IRQ? Huh? Let's just do this. I have deleted. I have fucking deleted you. Yeah, I have. IRQ. Okay. And so either way, these are also there. Right there. First use in this function. Did you mean IRQ handler? First use in this function. No shit, because they're in here. Right there. Sometimes make is a little bit dumb. Like I am doing a make clean, clear, and make run, which should strip everything, clean it up, and rebuild everything from scratch. Actually, let me just do a absolute from scratch. Same fucking result. Oh. Maybe also be in the correct project. That usually also helps a little bit. Yeah. We are registering. We're doing a register. Yeah, but it says that we haven't unhandled. Even though it should be going through here. and not through here. Uh, and I'm 100% sure that I am not supposed to be calling that thing. No, it should be hardware bound. Like actually, like the hardware should be doing all the work, and not me. Uh, we're doing yes, we are doing IRQ register handler number one with that handler. We're setting the handler. We are removing the mask from that handling. Then we are doing all of that. But what? This is so fucking stupid. Like, we're just gonna here, gonna serial, unhandled intro 33. Even though it should all work. Okay, so what happens if I try to write shit? Nothing. New idea. Instead of doing this here, we can do an unset here. Then down here, when we are doing everything. So that one came from up there, yes, Gucci. Then we can do this. That needs to be calm. Then we need to do H6. Needs to be capitalized. Then we'll try to set the bit now. Which again I have a function thing for that. So if we then say write controller, then do again conf, and try to do it like this. What will we then get? Devices are initialized, everything is present, and everything is good. Okay. If I then go again in here and then do a nothing gets typed. And nothing at least appears to be typed. I'll just try to just reset it here. Do all this. Oh, I press H and it did something. That's then also it. Let's try H again. Okay, yeah, something works. Something does work. Okay. But now my IRQ ISR systems does not work now. Always fun great. When they don't work. Yeah, okay. So the half is here. That's not there. Yeah, so here we do ISR initialize gates, do that, and disable the gates 80. In here, we're getting the device driver. Then we're getting all those. We're probing them all and setting them to be the primary device, seeing if it's null. Then we found PCI, found -s PCI. Maybe I should also really quickly do that. Actually, found -s PCI. Then register those for each of the 16 IRQ lines. I have a feeling that that is wrong. Just a small feeling that that may be wrong. But of course, I could also be extremely wrong here now. Let me see. So, yeah. Huh? Where did the fuck did all of this extra logic didn't come from? Did I get confused between this one and the other one? No. Okay, so new developments has been made. And let me guess, does this one also then get called from the ISR handler? No. But still, that is okay. Okay, new developments. All of this, and including this, is not needed. Including this. And wait, no, wait, I'm on a different thing here. 2 seconds. Is now, nope, not even also on the master. So yeah, okay, so this was on the wrong repo. So if I then go under here and enable those two, we should also enable drops. This here should be disabled, and this should also be disabled. I've just looked through my original implementation of everything, and yeah, Do you see anything? No. Anyone up here says anything? Yeah. First channel, no ACK after there. Wrong repo again. Okay, so no ACK after. What's that? That's here. Resetting. That's after resetting the device. But then we try to read this one and everything. Nah, maybe it's actually not because that. Maybe it's because that doesn't work. Maybe. Oh no. Like, because, okay, two things. First of all, what do we get up here? You say all of this. Why are all of them on 33? That should not be the case. That is for sure. So we should say I and to there. Then we do this. We still get this. I have a feeling I know why that comes around. Of course, this is only a feeling, but if I enable interrupts here, nothing here, okay. Then we still don't get anything here, okay. It was worth a shot. Just during IQ handler for IQ 1. I have a feeling that it needs to do 33 here instead. For 33 here, because that's where the other ones here are. But wait a second. No, wait a second. This is wrong. If I do IRQ here, okay, nope. Yeah, shit ain't working. Even though it should. Like, yeah. I just have a feeling that. Okay, so to the uninitiated, the base of most of this comes from this repo here, from Nanobyte OS, right? Which is which is what's it called? Yeah, which is an OS that does a few things, all those things. Now, what I would guess is that this would have been somewhere else in here. No, it's not. I would have thought that the ISR right? The ISR here, if it went to this, it would call that function. Another thing that I also would have thought, that if I open up this one, and then I check out the ISR ASM thing here, because all this just ends up at the ISR right here. And it includes this auto-generated file. I also have this, by the way. This auto-generated file fills out this all these things here. These are all macros. This file here actually defines the functions and also sets all of them. All the ISRs, pretty much. Go down to 33 here. We can see it goes to ISR I686 ISR 33. And then go up to here, this macro here, 686 ISR %1. %1 means a variable, a something pretty much. And then the implementation. Push a dummy error code, then push the interrupt number, and jump to ISR common down here, which then calls this. Okay? So why all this is not working, I don't know. I thought that May could work. Note I'm bridging the going between like the lines of what you actually should do and what you should not do. Is that we have a line, we have a call here to IRQ with the handler. Now the IRQ handler and the ISR handler are two different things, but they're the same in practice that they both have the same arguments. They will always have the same arguments. So yeah, okay. Now I just need to figure out why this ain't working. What did I do differently beforehand? I did this beforehand. Let's just try to enable interrupts first. As the first things ever. Yes, we did enable it. It is present. There's no errors. If I then go through, there's it. Nope. Idea time. Because we have this here. And then go back to here. We still have this here. Then we just need to do we just need to read in the configuration. Again. Is it maybe a little bit wasteful? Nah, maybe. But hey, no one said that this would be clean. So now, this one nothing. Now we got this. Yeah, we can't do this one. Or maybe actually we need to wait until both the input buffer and the output buffer are both empty. Because Yeah, wait until that. Then then we can idea time. I have an idea. What if we flush it? What if we flush the input like this? Just flush all of it out. No input, okay. We still have the, oh damn it. A swap shot. Also, it's output buffer that we need to flush, not the input buffer. Input buffer state. There. We don't need to flush the input, we need to flush the output. No input. We got no errors. Which means that my theory is correct. For once. Now if I just do this properly also. Input. Still correct. Nothing up here is wrong. We're doing all that. What if we both do 33? What if we both do 33 and 1? Nothing? Okay. Still not getting anything. Like literally nothing. Like, yeah. Like, yeah, nothing. We're getting absolutely zero. Nada. Let's do a let's probe it with the UART. That's under drivers serial UART dot write f string com1 format. Interrupt request dash u IRQ. Then we can check we are absolutely not getting anything. Like absolutely not getting anything. If we're just checking we should also check this. And also remember Bjorn backslash r backslash n. Actually, wait a minute, two things. That's because that's no way two things. UART should be initialized here. When is UART initialized? UART is initialized as the absolute first thing, so yes, it is initialized. Okay. What else can it be? Rewriting it down. What if I read it again? write down. Yeah, so yeah, we are reading it here. We are flushing here. We're checking if it's present. We do that. We enable interrupts yet again. What if I try to set it here? Like at this point, it's just trial and error, pretty much. That's the name of the game, pretty much right now. Didn't even look at the UART. UART has nothing. And again, nothing. Nope. Like we should be able to get at least something out of it. Like I have done it to the, like pretty much to the bone. Everything. Initialize. We are flushing. Disable the 2 channels. Flushing. Checking if we've done it properly. Writing into the channels. Then performing the control self check. Enabling the two things. Writing into here again, reading here. Then disabling the 2 channels again. Test the channels again. Write DMD there, all that. Successful. Then we read it again. Enable interrupts here. Write it back in. What if I just do not do... Which one was that? It's this one. In 1 step, but only in 2 steps. If it's present, then we'll do that. And again, if it's present, then we'll do that. Here we're gonna delete you. Delete you. This one will not be then used anymore. Read the configuration here. Yes, it is. Everything should, again, should work. Input, nothing. Serial, nothing. Errors, nothing. It's absolutely f***ing... What if I... Alright, yeah, that's that. Good morning. What if I do the ISR handler here? What if I do both? Like, what will then happen? Nothing, no interrupts, and no errors. What did you say here? Registering IRQ handler for IRQ1 handlers equals there. Let's try to do what we did beforehand. read the config to a before. Let's do it before. We have a dash B. Yes, Visual Studio says that that is not. That is not a valid thing. But I will say you, yes, it is a valid thing. What do we then say here? We need to look for a before read here. Ah. Bits have been flipped. There are bits that have been flipped. Bit. Let's see if we can find them. Bit 7 has been flipped to 1. Bit. This one has also been flipped. That's the translation. And port clock has been enabled. And you have been disabled. What are you have been flipped too? That should be 0. And then second port interrupts has been enabled. Both of them has 0. But why the fuck has that one been enabled? And what else was it? Bit 3. 0, 1, 2, 3. That's also. We are flipping bits all the fucking time, apparently. I have a feeling that's because of that we are reading. So let me just like redo that. Anything in here? Nope. And of course, still no errors. Okay, even if we try to just write it, it does not work. Wait until the wait a minute. Is that the input buffer is empty? Yeah. Just wait for a moment until everything has been cleared out. Nothing. And hell. Nope. Okay. What if I actually just like say if support all that, and if I then say support second port, and again here support second port, and if, and then down here and if here, do all that. First port, second port. Okay. Now all traces of the second port has been deleted. And so now the second port still gets the fucking gets an interrupt. It gets this interrupt like thing set. What if I like try to set this one here? Just out of curiosity. What will then happen in here? It'll be flipped. Something in the initialization process just doesn't work. I think, like, yeah. Either that or something is terribly wrong. Like, absolutely terribly wrong. Okay, let's again go through the steps. So we have the steps right here. So let's go through them again. Woohoo! So disable devices. Flush the output buffer by reading from 60. By reading from 60 and checking if the output buffer state is, that was not the one, this was the one, until it is, as in this one up here, 0 means empty and 1 means full. We need to check if it is empty, and there's something. Maybe if I do it now. Nope. And nothing. Okay. So flush. Set the command controller config byte to, you want to disable IRQs and translation for port 1 by clearing bits 0 and 9 and 6, sorry. Unset and unset. You should also make sure the clock signal is enabled by clearing bit 4. Okay. If we go down into here, we can see where am I? Up here. We can see what each bit does. We can say clearing bit 0 disables IRQs, clearing bit 6 disables translation for port 1, and clearing bit 4 enables port clock. Enables the port clock. Right? We are doing that here. Pushy. Then of course, write it back. Perform the self-tests. It is as simple as reading in that one. No, sorry. To test that one, send command AA to it, then wait for a response and check if it replied with 55. Let's see. We write AA to it, and then we do that. Okay. Determine if there are two channels. Determine if there's two channels. Send a A8 to enable the second port. We are doing that to both of them. You guys didn't even get through the purge. Yeah. Then that and read that one. Bit 5 of that one should be clear. If it's set, then it can be due to dual channel PS2 things, because the second channel should be enabled. And do I send command 7A to disable the second port again, and clear bits 1 and 5 of that one to disable all that. Cushy. If this one is present, then wanna do here. We then also need to unset. What was it? We need to unset bits 1, disable interrupts, and disable, what was it? Clock, as then enable, so enable clock port 2. That's then by clearing, and that's then bit 5. Only if it's actually down. Okay. Then perform interface tests. This is where we send AB to test the first port. Check the result. If it's a dual channel controller, use command A9 right there. At the stage, check to see how many these two ports are left. If there ain't any that work, you give just okay. Now we then get into enabling the fuckers. Here we are setting handlers and registers and whatnot. As stated here, if you're using IRQ, recommended. Also enable interrupt for any usable PS2 ports in the controller config byte. Set bit 0 for the first and or bit 1 for the second port. Then set the command. Then set it with the command 60. Okay. Maybe I should really actually unset here. We don't need translation. We just need to unset it. And there, yes, and write it in. Then we can do it proper. The way that we do it proper is that we check if the port exists using this. check if it exists, and command that one. Yeah. Once initialization is done, all PS2 drives, if any, should be reset by the driver. The devices should be reset by the driver. This can be done by sending the byte FF, supported by all the PS2 there. Put 1, all that. I'm waiting for a response. If the response is FA, AA, you will check for FA and AA. If I'm not fully mistaken, this actually checks. This should actually check for AA. It does not. This one only checks for FA. We're not actually checking for anything. For the second part of it, but yeah. Then the device reset was successful. If the following response is FC, then the self-test failed and should be ignored and all that. Yes. Yeah, it did go through. Then in here, we don't wanna check for any for what type it is. So I wanna say disable scanning command for the device. Wait for the device to send back an acknowledgement. Yeah. Then the identity command. Wait for the device to send back an acknowledgement and response. Then we can get back the data. Then down here we should also enable one back again, which we also do. Okay. Let's check if this also works. So set up some timer or a counter for to use as a timeout. Pull bit 1 of the status register until it becomes clear or until your timer until your time expires, and then write the data. Let's do this down to the bone real quick. So yeah, we'll make a 32 6. Let's just do that many 6, I guess. Let's actually do full screen real quick. And it was the bit 1, the input buffer empty/full until it becomes clear. So yeah, while now wait, actually let's do a 4 6 if in byte status port bit get here it was input buffer state. Okay, so until the input buffer state becomes clear, then we should break out of it, unless but if okay, so we'll really quickly also check right down here if it's set something fucked up. We'll write it out, log error, writing to first channel failed due to timeout. And then we can write the data and all that jazz. Nothing. Any interrupts? Nope. Any errors? No. But now it is even more fucked. Why? Using interrupts is easy when like you once occurs you there's no need to check bit 0 in status register 2 seconds. Am I actually not even I am checking bits I am 100% checking bit 0. Wait for an acknowledgement, all that. No, we're checking bit 1. Send the end of interrupts, all that. There's one problem to worry about. If you send a command to the and invokes a response, the PS2 controller may generate IQ1, IQ2, or no IQ, depending on the firmware. When you push the response byte into the buffer, in all 3 cases, you can't tell where the byte came from. Okay. Just don't, I guess. Yeah, so this one should actually be unset. The configuration here should very much be unset. Let's just hopefully not worry about that. I hope. Also, wasn't there something like that we need to clear 2 bits? Yeah, that was those 2. Yeah, okay. Unset config for bits 7 and 3. 7 and 3. Because they need to be like not set. Okay. But it did go through. Still again, yes. Okay, this actually begins to fucking piss me off. Oh. Hey. And again, the device can be any one of these. Like I say, it could also be a mouse. The 100% is like 100% real. It could also be the mouse. Set bit config translation for port there, and then unset bit 4 for that one. Actually, was bit 2 ever fucking default 2 seconds. I need to check. Then B. Total of 0 padding, 8 bytes, 8 bits. Forgot to do that. And also no interrupts. Nope. Still no interrupts. What are we saying up here? Bit 2 is at least not set. If bit 2 has been set, as I say, pretty reassuring here. Your OS shouldn't be running. That's great to know. My OS is running. But the device isn't running. What if I again interrupt? Nope. Again error? Nope. Yeah, this is actually beginning to piss me a lot off right now. What if we do an I8042 write controller config? What if we try to write it back in again after write, after read, hopefully all of them should be the same. If they aren't, all of them are the same. Gushy. Okay, now what about okay, nothing's happening there. Oh, for fuck's sake. Just try to put it pretty here too. Like, what's the worst that could happen? I don't know why this is not working. Like, everything should be working, but apparently not. So, like, first child present. Okay, let's just look through what else is happening. Yeah, because then it's just like some general like checking if everything actually works in gathering LED data. And then that's it. Yeah, gathering LED data, processing keys right here. And that's it, yeah. What about in this one? Keyboard attach. What do we say here? Here we say a lot of things. Oh, right, yeah, that's this. Keyboard init, keyboard cache, a whole bunch of things. Here's two keyboard inits. Yeah, so, yeah. I don't know why the fuck this ain't working. But yeah. I will be making a later stream at some point. If I fix this, of course. Or, yeah, if I fix it. If I don't, then I will also still stream and do everything. So yeah, with that, I'll say thank you all for watching. Thank you all so much for watching. may you all have a test day, and I will see you all next time. Goodbye. Maybe I should also stop the stream before I close OBS.